Action?
Go ahead, Terry.
All right. Good afternoon. Before we get started, I want to apologize. Tom asked me to give a little demonstration or show what we're trying to do for the domestic hot recirculating system. He did inform me that there would be hair and makeup, but I come up here, there's no hair and makeup. So if I don't look my best, please have a talk with Tom. Okay? But anyhow, I'm here to address, he wants me to address the problem we are having with the domestic recirculating system. I'll explain it as quickly and as easily as I can. I'm here on the 6th floor, Tower 2. We have 4 pressure reducing stations in each tower, 6, 14, 22, and 29. As you can see, this is the hot water coming in to this station, right here. It does exactly what it's supposed to do, reduces the pressure so that the people in the condos can use it. This is coming from this roof, from a 750-gallon water storage tank. It comes all the way down, but by the time it gets here, with the static head pressure, we're talking about 240 pounds. And this all makes sense a little bit. The cold is up here. The cold comes from the pump room down on the 1st floor. And right now we're at about 130, 140 pounds. So there's about 100 pounds difference in pressure. We are using that to our advantage. What we are trying to do is, as you know, the original system has failed beyond repair. So the first thing we tried to do is put this pump in. Stainless steel pump, simple, and all it does is it pumps water, hot water, recirculates it all the way down the hallway and all the way back, so that hot water is everywhere it needs to be when people need it. Works great, most of the time. The problem we're having is late at night, late, must be 2, 3, maybe 4 in the morning, people aren't using hot water. This is still working, it's still pumping water, but the water, nobody's adding any hot water or using it, so this whole system cools off. And the trouble is, the first person up in the morning, this covers 6 floors. The first person in these 6 floors has to really run some water. It's aggravating and it's wasteful. So we're trying to do the best we can to solve this problem. We came up with an idea. We short-circuited the hot with the cold. And I'll explain it. As you see here, we have this is hot water. It's going down through here, through our system, through a pump. This is a new pump, and this is an automatic electronic valve. And back through a backflow preventer, and into the cold water. What we want to do, and we have a control. Tom will show you over here. A 2-stage control that controls what we're trying to do here. And what we're doing is monitoring the temperature of the loop, the recirculating loop. When the temperature starts to drop, whatever time that might be, 2, 3 in the morning, that's going to start monitoring it. And this is still a work in progress because Tom and I are trying to figure out what temperatures are the best to make this work as best we can. So, in fact, he's been talking to some of the tenants to see how their water is. Anyhow, for now, we have this starts to cool off. Okay? That control senses it. It's 2 stages. The first stage opens up this valve right here. That valve, because we have such a difference in pressures, 230 to about 130, 100 pounds, all that valve has to do is open up and it starts sending hot water, but it's not hot, it's lukewarm water now, up through here and into the cold. Okay, so it starts doing that, sending lukewarm water, and then we'll bring it all the way down from the roof. Okay, until it starts to get warm, until it starts warming up. It'll sense that it's warmed up. It's not going to be hot because I can't put real hot water into the cold, but I can give it enough that it's not as wasteful and it gives us a head start. In fact, what I think is going to happen is by the time it gets here to be 80, 90 degrees, the rest is a lot hotter. You know, this is going to be the coolest spot in the building. So that's going to warm up. When it warms up to its temperature, the valve shuts off. And everything, and it'll keep doing that off and on, until people are really out there using the water. The second scenario is this valve opens up, lets the water up into the cold, and the temperature keeps dropping. This valve can't keep up. That control will sense that, hey, we're not keeping up, we need help. So it will turn on the second stage, turn this pump. Now that thing will do a couple things. Obviously it'll move more water, and it'll move more water up here. If it needs to, it can send cold water all the way up to the domestic storage, hot water storage tank. You know, so then that'll really move water to get, once the temperature warms up again, it'll shut the pump off, and once it reaches the temperature we want, it'll shut the valve off. That's what we're trying to accomplish. And like I say, we're working on how this is working and what temperatures are the best, and that's going to be a work in progress. If you have any questions, you can talk to Tom. I think he understands this better than I do.
I don't know about that.
Yeah.
But you're a good teacher. A couple things. I know initially when this was designed, the thought was you'd have to put this in each one of the stations in each tower.
Yes.
But now you seem to think, and we're gonna talk to owners on different levels to see if this is happening. But you seem to think if we put one of these in each tower, that's
on the bottom floor,
on the bottom floor,
floor,
that may satisfy the heat, the hot water demand.
This isn't going to be a perfect solution, but I think it's going to be a solution that maybe we can live with because of the deterioration of the original system.
So let's talk about that for a second. So for those board members that don't know, there was an original domestic hot water supply system in the building. Mm-hmm. It was decommissioned a number of years ago because of leaks and the inability to be able to replace piping and things like that. Right?
Here's what I believe happened with the system. The only thing the system does that our system isn't doing is